All right, hello. I want to have a little Sig Fig review for some of you today. And here's what I want to do. What I want to try to do today is I want to try to kind of make this review not only just a quick review of the rules that we've learned, but I'd kind of like to do the best I can to make it sort of realistic. And what I mean by that is realistic to real life. And before I even get started, I'm going to throw another item at you, and I'm going to remind you of something, and I'm going to remind you that we have learned that precision and accuracy don't necessarily mean the same thing. You know, we can have a good degree of precision. In other words, we can get the same measurement multiple times. Remember shooting the arrows. The arrows may be clustered together over here, but they may not be in the bullseye. So we may be getting similar measurements, but we're not getting the right measurement. And so we want to be precise, but we also want to be right in the bullseye, and we want to be accurate. But we tend to kind of throw around the words precision and accuracy. I mean, obviously we want a measurement tool that is precise as possible, and we want it to be accurate. So, you know, so for the purpose of today, you know, I'm going to use the word precise a few times, but just remember that we want to be as accurate as we possibly can. And I would think that as our level of precision, if our tool is very precise, then the higher the level of precision, the more accurate we would be. Except for the purpose of the rest of this, I'm just going to say accurate, okay? Because at the end of the day, we certainly want an accurate measurement. So here we go. Significant figures are the number of digits in a value, often a measurement, because let's make sure we understand something. Yeah, let's talk about Sig Figs, and yeah, Mr. Day throws made-up numbers at you. But at the end of the day, okay, significant figures play a very important role in measurements. Now, so significant figures are the number of digits in a value, often a measurement, that contribute to the degree of accuracy of the value. We start counting significant figures at the first non-zero digit. Okay, it sounds like a mouthful, but let's see if we can understand that. So, what I want you to know is that a lot of times we have what I call overarching principles. So, like the big picture. I'm just trying to get you to see the big picture. So I'm just throwing made-up values. I'm just throwing made-up values at you. Well, is that bad? No, it's not bad because I'm helping you understand the big picture. But is it also realistic? Like, for instance, when we make stuff up, and we're all guilty of making stuff up, see ya, okay? That's just a made-up item. So instead of making things up today, let's also try to have this conversation. Let's try to be a little bit more realistic. For instance, let's consider a triple beam balance, which we have considered before. You have a beam that measures in the 100, okay, in an increment of 100. You would have a beam that would be an increment of 10. And you have a beam that if you went between this 2 and this 3, there'd be 10 little lines. So every line would be 1/10 of a gram. So this tool has a level of precision that would essentially be basically just, to 1/10 of a gram. But for the purpose of trying to not confuse anybody, I'm just going to start talking about accuracy, okay? All right, so here we go. This particular tool, if you had 100, a 30, and a 5, and then you had 5 little lines, you would have 135.5 grams. How many Sig Figs would you have? 135.5. You would have 4 Sig Figs. Now, what is my point to you? My point to you is, so instead of making up some value, that's an actual value that could come from this tool. But the greatest degree, what's the greatest? You're only going to have, the greatest you're going to be able to obtain from this tool is going to be 4 Sig Figs. that's going to be it. That's what you're going to be able to get from this. Okay? All right, so what about this tool right here? What about this meter stick? Well, the meter stick is very similar to the triple beam because it's measured, there are 100 centimeters in a meter, but then if you go in between the centimeters, there's only 10 little lines. So that's, once again, it's going to be a tenth. All right? Now, we refer to that tenth as a millimeter, but if you had a number, if you had 13 and then you had 5, what would you have? You would have 13.5 centimeters. How many sig figs would you have? This is the important thing to grasp today. How many sig figs would you have? Well, you would have 3. 13.5 would have 3 sig figs. Now, what's the point? Well, the point is simple. The point is that these sig figs are actually coming from something. They actually have real life meaning, and they're coming from an actual tool. Okay? All right, so we're going to talk about the 6 rules, but we're going to talk about the 6 rules as realistically as we possibly can. So I'm going to show you this picture because this is very interesting. At the time of this tool's purchase, it would have been about a $5,000 tool. This particular tool, okay, I just took it, I turned it on, and on this pan, the balancing, I put a rubber band. When I put the rubber band on there, this is the measurement that I got. The measurement is 0.6875. How many sig figs would this particular measurement have? Well, we know that this 0 would be not significant, so it would have 1, 2, 3, 4. So this is an example of a real life measurement, and this measurement was able to go all the way out to the 10,000th place. So 1, 2, 3, 4. Now, this is where everybody starts getting confused, using the words precise, using the word accurate. Well, this is what I'm going to offer up. I'm going to offer up that this is a more precise tool, has a higher level of precision, which therefore should make it more accurate. Okay? So here it is. Real life values today. So I'm going to go through the 6 rules, but I'm going to give you real life values. I'm not just going to make stuff up. I'm going to give you values that, are more true to life. Okay, this is definitely a value, obviously, that would be true to life. So we're going to use realistic values versus just trying to learn a concept. Now, are we going to try to learn the concept? Yes, we're going to look at the rule, but we're going to use very realistic values today. Okay? And you may find that simpler. So rule number 1, I have 3 values. Could I definitely, are these within the realm of possibility? Yes. I might have a tool that could measure, obviously like a triple beam that could measure to the 10th place. Maybe there's a tool that could measure to the 100th. Maybe there's a tool that could measure out to the 1,000th. I don't know. But the point would be, how many sig figs does each one of these numbers have according to rule number 1? Well, they're all non-zero digits. So 3, 3, and 4. Okay, so that rule, you got to admit, is pretty straightforward, pretty simple rule, but do you understand that the rule has a real world application, and do you understand that these numbers, if they're measurements, came from some type of measuring device? And the number of sig figs was based on that piece of equipment's, ability, measuring ability. Okay? All right, so rule number 1, easy. Rule number 2. Rule number 2 is the rule where you have zeros sandwiched in between non-zero digits. So because these zeros are sandwiched in between non-zero digits, they are considered what? They're considered significant. So how many significant figures here? 4. How many here? 3. How many here? 1, 2, 3, 4, 5. There are 5 significant figures on this particular value. Okay? So you have 4, 3, and 5. All right? So that is rule number 2. And once again, rule number 2 is pretty straightforward. Okay? All right, so that's pretty easy. So let's go to rule number 3. All right, now you'll notice on rule number 3 that I put a little sticky note on here, and it says take note. Okay, well, the reason why it says that is because I want to draw your attention to this is the first time you're going to hear me say not significant. Okay, so think about that. So rule number 3 has zeros that are to the left. All of these zeros are to the left of a non-zero digit. And there are even zeros to the left of the decimal point. So what does rule number 3 say? Rule number 3 says these zeros are only acting as placeholders. Therefore, they are not considered significant. So I would have 2 significant figures here. I would have 2 here, but I would only have 1 there. Now, don't overcomplicate that, okay? Don't overcomplicate the rules. The rules in themselves are really not that complicated, but the reason why I started the way I started today is because I also need for you to understand that these values don't just come out of thin air. These values could be measurements, and the significant figures, are tied to the numbers for sure, okay? But remember that the numbers could actually represent something in real life, okay? Rule number 3, pretty straightforward, 2, 2, 1. What about rule number 4? Rule number 4 is where we find zeros again, but the zeros in this case are to the right of a first of all, a non-zero digit, but they're also to the right of a decimal. Now this one is sandwiched in between. So what do we know about these zeros? We know that they're all significant. Now this is where, so first of all, we say how many significant figures? Well, easy, 5, 3, and 4. Okay, all you gotta do is count. Now if you wanna know what's the difference between these zeros and the zeros from before, well, it's simple. This measurement, whatever tool this was capable of measuring to the 1,000th place. It just so happened this was even. It was a 9. But the tool was capable of going out to the 1,000th place. So these zeros would have to be considered significant because they're part of that very, very, a little bit more accurate, I would have to think, or precise measurement. And once again, I know that's where we kind of almost seem to use those words interchangeably. Once again, I know that we told you you could be precise without being accurate, okay? But I would have to think that if you raise your level of precision, you will also raise your level of accuracy, okay? So this tool is probably a little bit more precise than this one, which this one and this one kind of go out. They probably have the same level of precision, okay? But that doesn't change the rule. The rule is they are considered to be significant. Okay, what about rule number 5? Well, rule number 5, once again, you got a Post-it note. Why? Because you're going to hear me say not significant again. So what do you have? You have zeros that are acting simply as placeholders, except these zeros are obviously your zeros that were acting as placeholders before were over in here. I understand that. But these zeros are simply acting as placeholders. They're not really telling us about the accuracy level or the precision level of a piece of equipment. They're just acting as placeholders. So we don't consider them to be significant. So what do you have? You have 2 Sig Figs, 1 Sig Fig, and here you have 4 Sig Figs. Okay? So once again, these are numbers that we could probably imagine using. Okay? These are numbers that we could probably imagine using. So are these. So are these. Okay? And so are these numbers. So today, we're trying to talk about Sig Figs with numbers that we could actually imagine using. Okay? And then the last rule is the unlimited rule, which a classic example of that is just counting. So if I needed to count the number of people at a festival, then that's just an unlimited. I'm just counting how many people are there. That's an unlimited Sig Figs. Okay? So we go all the way back to our first definition. After talking about this together, significant figures are the number of digits in a value, often a measurement, that contribute to the degree of accuracy of the value. Okay? Significant figures. So here we go, one last time. Here's a perfect example. this tool is where we're getting this measurement, but we are getting our number of sig figs from this measurement because of this tool. All right? Have a good day.